Hello and good day. My name is Andrew Galston. I'm the EMEA Director of Business Development for AT&T Cabling Systems. Today we're going to talk about smart buildings and how to cable smart with CablingGuard. First, let's start by discussing what is a smart city. It's a big buzzword at the moment. A smart city consists of all the utilities and businesses and companies inside a city, such as power plants, waste management, law enforcement, schools, IT, hospitals, telecoms, and other businesses. They're all producing data, useful data. What a smart city does is assess that data in real time to optimize and sustain growth of operations of that city via a site-wide network of sensors gathering data. This enables the government to service its citizens better and attract more tourism and investment into the city. Smart cities start with smart buildings. A smart building is the physical world plus the digital world. It gives you a smart building. The physical world we all know is our infrastructure, such as IT, BMS, our network of sensors, security, 5G, plus the digital world, the machine learning, new human interfaces, AI, OT and IT integration, big data analytics, to give you a smart building that can adapt in real time to needs. It can improve productivity and give satisfied occupants, and build safe, efficient and reliable buildings. Why should we care about smart buildings? Because first you want to look at inviting tenants. You want to get more revenue from your tenants by differentiating yourself from other buildings. You want to maximize the rent per square foot and generate and add more revenue for new services. You want to optimize operation and maintenance investment costs by improving performance and mitigating risks, by generating insights and ensuring business continuity. Smart buildings create competitive advantages. They transform data into insights and insights into actions. They help improve corporate cost structures by streamlining workflow and giving real-time operational management. They differentiate yourself in the market, help you to improve occupancy experience, ensure strong positive reputation, connect buildings with technology and technology with people. This allows you to focus on your core business, enhance revenue generation opportunities, eliminate distractions, optimize conditions for individual occupants, which will improve productivity, all the while mitigating and reducing risk. Prevent issues before they happen, respond effectively to unpredicted dangers, and be proactive to changes. How can AT&T Cabling Systems make smart buildings a reality? With CablingGuard. Why do we need smart cabling systems today? 80% of downtime is directly caused by people or human error. 70% of network downtime is related to cabling problems. 40% of employees move within their facility on an annual basis. IT managers spend 39% of their time in fault management, whereas 80% of that time is trying to find the problem and 20% is actually fixing it. Unused network equipment can be as high as 40%. Around 50% of all cabling is installed for redundancy without any real-time status information. So if it does fail over to the redundant link, how does the IT manager know it's actually going to work? Cabling documentation is manual and has no online reference, and if it's done poorly, you can lose 2 to 3% capacity of your data center. Cabling usually has the lowest level of security, and no one is monitoring it in real time, but it is a gateway into the network. Poor management and no security is a critical problem. If you have an installation and a very poor administration, in a very short period of time you can go to a very serious patching mess. You can have this situation on the left hand side of the screen where if you wanted to do a move, an add or a change, it would be very difficult to organize the same. You would have to remove all the patch cords, repatch again. It's a lot of downtime. If you wanted to fix a problem very quickly, it would take a long time to do it. And if you wanted to do an upgrade, you would probably have to build a new data center and then refurbish the old data center, which is just not practical. Whereas the real situation we want to be in is on the right hand side. It's clean, you can adapt to changes very quickly, you can find problems quickly, it's very well organized. You need a system that can help you do that. Intelligent infrastructure management for structured cabling has been around since the 90s, since 1996, but it's only had a 2 to 3% market share. But if it's so good, why isn't everybody taking up the intelligent cabling? And the truth is, it has had a high cost to value ratio. It's nice to have, but not for the cost. The cabling industry is a servant of two masters: the building owner, and they have a budget that they want to stick to, and the IT manager, who has an opposite interest, who wants all the gadgets and all the software to make his life easy. So the industry came to market with a smart cabling ready hardware, which could be upgraded to intelligent systems at a later date when the customer had the budget. However, the ready system was still only ever used in enterprise cabling or data center environments only, and the price was still very high, so it wasn't considered as a mainstream product. Most solutions use non-standard patch cards for the sensing. So in the patch cards, they will have a RFID chip or a 9th or 10th wire that is detected by the patch panel. But they force the customer to use non-standard cabling, and if you plug in a normal patch card into that panel, it will not detect the patch. It gives you zero security. Also, if you want to upgrade from a ready to enabled system, you'd have to remove the standard patch cards and put in intelligent patch cards, which means downtime. It's not practical. And these are not stocked. They're bought for the projects, and they're about 4 or 5 times the normal price of a standard patch card, so it's very expensive as well. The intelligent solutions are forced onto tenders to differentiate competition in tenders, and they force the customer to buy another manufacturer's product without giving any real value. More than 60% of the intelligent systems that are installed, they're not used after installation. They're put on to be future proof, but they're so complicated that the administrators, they don't use it. AT&T Cabling Systems have looked at all these problems, and we've come to market with our own solution called CablingGuard. CablingGuard is our physical layer management suite, which consists of hardware and software, and we'll take a closer look at that now. How does CablingGuard actually work? So, in each network room, we install a cabling analyzer, an infrastructure analyzing scanner. This is connected to the patch panels with a normal patch card, and it's collecting the physical layer data. It scans each cabling channel on a port-by-port basis, recording any changes in real time, and this information is given to the server over the network, which gives you a physical representation of your entire networking architecture. Then, when any changes happen versus the scanned versus designed, the changes that happen on the network, an email will go to the administrator saying there's been a change and you must investigate, and it will show you where the change has happened. In this slide, we have an example of a 4-connector and 2-connector cabling channel, and I'd like to explain how we can make this an intelligent cabling system. As you can see, we have a switch connected to patch panels, then the panels are connected to the consolidation point, and then onto the faceplate work area outlet and onto the device. Panels can be arranged in a cross-connect with 2 panels or interconnect with 1 panel. A cross-connect is used in large enterprise networks when the end user has expensive active switches. They will patch one time to a presentation patch panel, and thereafter all patches happen between the patch panels. If a patch panel port dies, it's very easy and inexpensive to replace a jack inside the panel rather than replacing an entire switch. The switches are then locked inside a secure cabinet. This is best practice because it improves security and extends the lifetime of the ports on the switches. An interconnect is more common in smaller fixed environments where cost is a concern and they want to maintain fewer connections in the cabling channel for improved performance. So how do we make this an intelligent cabling channel? First, we install a cabling infrastructure analyzer in every network room where intelligent panels are needed. Then we connect each patch panel to the analyzer via a normal patch cord up to 50 meters away. Then any patches or disconnections that happen between the panels, the analyzer will detect and send an email to the administrator saying there has been a change. Please note here that the entire industry can do cross-connect patch panel monitoring with standard patch cords or special 9 or 10 wire or RFID chip patch cords. However, what happens when we need to monitor interconnect panels? When using special patch cord systems, they cannot detect the patch cord on the switch because the switches don't have RFID chips or a pinhole for the extra wires. They will inform the customer to add an extra panel to the channel, which can increase the cost and reduce the cabling channel performance, or they will ask to make a custom-made bracket to fit on the switches that will detect the special patch cords. These brackets do not fit all switches and are very expensive. With AT&T Cabling Systems, it is very easy. First, we load our CablingGuard application server and port licenses onto a Windows 2016 and SQL server. Then we connect it to the network and connect the cabling analyzers to the server. Then we load the switches with the IP ranges onto the software, and the software will pick up and monitor all layer 2 and layer 3 devices that are in the switch IP range. In this example, if the laptop IP drops from the system, an email alert will go to the administrator indicating the device is disconnected. The administrator didn't get any email alert saying there was a disconnection on the patch panels. Here. He opens the software and there's no red lights when he turns on the software. There's no red lights on the panels. So for a process of elimination, there must either be a disconnection from the switch side, or there is an issue with the permanent link from here to the faceplate. This is how we are able to do interconnect monitoring using standard patch cords with layer 1, layer 2 and layer 3 monitoring. In conclusion, this is how AT&T Cabling Systems is able to give cross-connect, interconnect and full channel monitoring with standard patch cords and a very simple architecture of analyzers and software. CablingGuard is a physical layer management suite that can manage your assets and your cable management and improve security, and it consists of cables, connectors and hardware devices. It is a patented system based on an infrastructure analyzer that sits in the communication room, and smart panels are placed in the physical layer channel, and it uses standard cabling products. It has an application server with port licenses, and for many locations we also have a dashboard application that can collate all the application server information into one usable portal. It's very simple to install, to train, configure and operate. It's out of band, purpose for focus on layer 1. It has a web-based access interface with unlimited users. We use no special patch cords. It has the lowest total cost of ownership in the industry. You can get a very quick ROI even on the first fault. Naked Smart Ready patch panels are almost the same as standard cabling, so if it's ready to install, all you have to do is put in a smart card and connect it to the scanner. The cost of doing the ready panel is almost the same as the standard panel. It's significantly less than other systems in the market because we make a lot of savings in training, installation and configuration costs as well. It can be integrated with popular network management tools via SNMP traps. It's very efficient. It can monitor 576 patch cords or 1152 ports, or we have a smaller version which can do 8 patch panels as well. The layer 2 and layer 3 MAC and IP address polling can be reduced to 60 seconds or 1 day or even once a week, and this minimizes network traffic. All it's doing is pinging for the devices, but it's a very nice option in the software. Low system power consumption as well, so each scanner only requires 30 watts of power, which is less than some light bulbs. The advantages of CablingGuard: it has a very good cost ratio at a positive level. It relies on collecting information from all its own sources. It recognizes any standard cabling component, including third-party cable products. It identifies layer 2 and layer 3 devices. It has peripheral asset management as well. It provides full security anytime and any place. It detects and raises alarms on changes in the physical layer. Provides full patching management and controls remote moves, adds and changes, including work orders. So if you've got a few sites around the world and you want to do some changes on a patch panel, you can go to your desktop, open the application server. You can start to do work orders by dragging and dropping one patch panel port to another, assign the work order to the administrator. They will get an email to go to site, and when they get to site, the lights will be flashing showing where the admin guy needs to change the patches. And once it's updated, once it's done, it will move on to the next work order, complete the entire schedule, and the documentation is already updated on the system. It's completed. A very simple engineer or even an office manager can do the changes. The system architecture is designed to work on cross-connect, interconnect, data center and work area channels with up to 4 connectors inside the cabling channel. So you can go from switch to device, or switch to server, or switch to switch using copper and fiber. The web client server application, it's based on Microsoft Silverlight. It runs on Windows 2016 and SQL. As you can see from the picture on the top left, it has a tree which shows the architecture of your entire company by building, floor, network room, and you can drill down and go into detail on what you want to find. You can bring up an elevation drawing of your rack showing the ports in use and the space available in the rack itself, and you can produce reports showing the space available as well. At the bottom you have a channel view which will show you the connectivity from switch to device, and if any connection in the channel goes down, it will highlight where the issue is. You also can upload JPEG files of the office layout or the building layout showing where all the points are located, where all your devices are located, and on the right side you have your properties, so you can do your labeling and you can keep a record of everything on the system. At the top you have work orders, alarms, you have discovery, reports and admin as well for doing all the different types of reporting and also admin on the software. The dashboard behind it basically will feed all the information from the application servers into the dashboard and give you detailed reports, and you can set alerts and thresholds for monitoring across the whole of your entire global architecture. Some of the key features of the CablingGuard application are shown here, which we've highlighted before. You can do work area, device management, move, adds and changes. You have a rack builder which shows you available space. You can do cross connect and interconnect. We have layer 2 and layer 3 discovery and SNMP. You can import your maps and do a lot of controlling features with those. You have a channel view. There are many different types of reports that you can use on a monthly basis to help plan and do new upgrades on the network. It has an online and an offline mode. So the offline mode is a manual entry system with no monitoring. You can upgrade it to online later if you want that automatic monitoring feature. But this is a very good solution if you want to incorporate third-party patch panels into the software, but you would have to do it manually. It also has multiple languages, and it also has a very useful help file for immediate fixes. So You can fix most of the problems in the software via the help file. However, if you want to go above and beyond the help file, AT&T Cabling Systems offers a 1-year maintenance on the software, which includes email and phone support, bug fixes and upgrades. So a closer look at the hardware. We have two types of scanners. We have the 576p and the 96p. We have Cat5e, Cat6 and 6a, UTP and STP. And we have pre-terminated MTP for data center with LC or SC on the front, and LC pigtail panels for backbone and campus-wide connectivity monitoring as well. The scanners are very efficient. We have one that can do 48 panels or 8 panels. And on the front they have 2 network ports or 1 network port required to connect to the switch architecture to talk to the server. This is actually very, very efficient, and as I said before, you can use one scanner to serve many cabinets. You don't have to have a scanner in every cabinet that has intelligent panels in. You can just connect the patch panels to the scanner via a patch cord up to 50 meters away, and it can be a Cat5e RJ45 UTP standard cable. There's nothing special about it. It's very cost effective architecture and very easy to implement. Just connect it up and off you go. The 96p scanner is a smaller panel. It's 8 panels for smaller IDFs. The scanners will talk to the server via the LAN, and you can jump onto any server or scanner via a web console. And as I said, connect the panel to the scanners via a standard RJ45 cable. The panels are shipped with 24 intelligent jacks, and then you have the LED strips that are above it, which come with the pack as well as a ready. And then when you want to upgrade to intelligent, all you need to purchase is a smart card, which is in red. Clip that into the middle of the panel at the back, and then clip the RJ45 into the actual device. So this clips in here, and then this goes off to the scanner. And then you're done. There's no downtime when you're upgrading from a ready system to enabled. There's no removal of patch cards because we use standard patch cards. We don't use any 9 or 10 wire or RFID, which makes it very simple to implement and very simple to upgrade to enabled. We also have fiber optic preterm MTP SC, we have LC, and we also have a pigtail version as well. So if you want to do some splicing on LC panels for single mode, multi-mode, from 1 to 96 fibers in a 1U shelf, we can do it. Okay. We are fully compliant with EMC and safety regulations. So in conclusion, should we now standardize our cabling architecture to be intelligent? And I think the answer is yes, because the return on investment is worth it. Our system gives smart global connectivity, centralized management, and it automates documentation. It gives simplified auditing, compliance, and change management. It gives asset management and capacity planning. It improves security and helps find problems very quickly. It allows you to do remote admin and work order for your admin guys. It helps give real-time monitoring of your passive architecture using standard patch cards. It's able to do interconnect and cross-connect, and also, finally, it improves operational efficiencies to free up your IT resources. I would like to discuss now a major project reference we had in the Sultanate of Oman. This project was won with Omantel for their HQ building, which was monitored and managed by Oman Tourism Development Company. They tendered the project for Omantel, which consisted of 2 office towers, a sun and a crescent, which was enclosed with a woven stainless steel cladding. The project consisted of an auditorium, conference room, offices and training facilities. AECOM was the original designer and SSH was the project management consultant on site. The project was awarded to Al Turkey Enterprises, and for passive infrastructure awarded to Al Tasnim Middle East. And AT&T Cabling Systems offered full training from our technical manager, who was BICSI RCDD certified. We gave design guidance and on-site support to ensure the project was a massive success. We gave supervision on site for pulling, termination and testing, with workshops for the CablingGuard software before, during and after, to make sure that the end user was able to maintain the system thereafter. The cabling system installed had 6,000 Cat6a UTP points and 2,200 fiber links with OM3. It was a fully intelligent enabled cabling system for horizontal, backbone and data center. We installed 45 network cabinets and 14 data center server cabinets with 83% perforation on the front and back doors and smart intelligent PDUs. The project has been awarded and delivered, and it has now had the Millennium Lifetime Warranty from AT&T Cabling Systems, which includes system performance, application, product failure and labor cost on site to fix any issues if it's a manufacturer defect. Copper and fibre installation was completed, and thereafter we invited another end user, the Ministry of Health, to come and do a walk around with the CI, and we showed them the design, and then we showed them the quality of the work. This is the front of rack patching work. The copper and the fibre was very clean, very organised. This is the back of rack copper and fibre management, which is bundled nicely using Velcro ties with enough slack to do any changes later. This is the intelligent connectivity example. So on the picture on the left there, you'll see that the cable is coming out, the copper cable is coming out of the fibre panel from the left side, and you can see from the copper on the right that the smart card is fitted into the middle and the RJ45 patch card is coming away, going to the cabling analyzer. For this project, we also supplied the server cabinets, which were a 1,000 kilogram load with 83% perforated doors front and back in a cold aisle formation. And we also supplied the IDF network racks as well, 42U 800 by 800. These are manufactured by AT&T Cabling Systems in Turkey. They come fully assembled and welded, very good quality. Here is an example and a screenshot of the CablingGuard software of the end user's site up and running. As you can see, we have a layout of their offices and where everything is located. We also have a picture of the rack just to the left of it, showing all the ports have been patched and the space available in the cabinet as well. Plus the tree on the left shows the floor, then it shows the room, and then the rack inside each room with the IDF rack name, and as you click on it, the properties would appear on the right. This is a closer view of one of the cabling channels that have been patched. You can see at the bottom it shows you switch, going to panel, going to faceplate, going to the device, and if the device was connected then configured on the switch, which at this time it was, the switches weren't up and running, you would see the MAC and IP addresses in the channel view as well. You can see IP and MAC at the bottom. This will show you close up on the layout of the floor plan as well, the outlets and the label for the outlets, plus if it's active or not in green and black. Very clean, very easy to find things and navigate the system in real time. This was just an example of rack to rack view. If you're going to do patches between racks, you'll be able to monitor those as well, and get a channel view for rack to rack connectivity as well. I'd like to thank you for attending our presentation. We hope you found it useful. If you would like to see a demonstration of the hardware and software of the CablingGuard, please contact your local AT&T Cabling Systems representative, or drop me an email and I will be in touch to arrange that directly. Thank you very much.